Tonight, you are about to travel farther into the future than any human mind has ever truly imagined. Far beyond the rise and fall of civilizations, beyond Earth, beyond the sun itself, lies a time when the universe begins to grow quiet. A future where galaxies drift endlessly apart, where the stars slowly disappear one by one, and where the night sky eventually becomes completely dark. Scientists believe this future is real. Not tomorrow, not millions of years from now, but across stretches of time so enormous that human history would vanish in less than a single second beside them. Tonight, you will drift through that distant future. You will witness dying stars, frozen worlds, ancient black holes, and the final fading light of the cosmos itself. But strangely, the end of the universe is not violent. It is silent, slow, peaceful, like the universe itself slowly falling asleep. So dim the lights, get comfortable, and let the endless cosmos carry you gently toward the final days of existence as we explore the most relaxing facts about the end of the universe. The universe is not eternal. Even the stars above us, the galaxies beyond them, and the endless darkness stretching across space will not last forever. Tonight, you are about to travel into the farthest future imaginable, far beyond Earth, far beyond humanity, far beyond the final sunrise that will ever shine across any world. Scientists believe the universe is slowly changing every second. Galaxies drift farther apart. Stars consume their fuel. Black holes grow silently in the darkness. And over unimaginable stretches of time, the cosmos itself moves toward a final state of silence. But the ending of the universe is not expected to arrive through chaos, not through giant explosions or sudden destruction. Instead, it may happen quietly, slowly. Like the fading of distant music late at night, you drift gently through deep space now. The stars around you glow softly against the darkness. Entire galaxies stretch across the universe like islands of light floating in an endless ocean. Each galaxy contains billions of stars, and around many of those stars, planets orbit silently through space. For billions of years, the universe has remained alive with light. Stars form inside giant clouds of gas called nebulae. Gravity slowly pulls particles together until temperatures rise high enough for nuclear fusion to begin. That fusion creates the light and heat stars shine into the cosmos. Our own sun works the same way. Every second, deep inside its core, hydrogen atoms collide and merge into helium. That process releases enormous amounts of energy. Enough energy to warm the Earth, light the sky, and support life across an entire planet. But stars cannot burn forever. Even the sun has a limit. Scientists estimate that in around 5 billion years, the sun will begin running out of hydrogen fuel. As it changes, it will expand into a red giant star. Its outer layers will grow larger and larger until Mercury disappears completely. Then Venus, possibly even Earth itself. The oceans will vanish long before that happens, The atmosphere will slowly disappear into space, and the surface of the planet will become too hot for life to survive. Yet in the scale of the universe, even billions of years are only small moments in time. You continue drifting peacefully through the cosmos. Far ahead, countless stars glow in different colors. Blue stars burn extremely hot and bright, but they live short lives. Some survive only millions of years before exploding in enormous supernovae. Red dwarf stars are very different. They burn slowly and carefully, using their fuel so efficiently that some may survive for trillions of years. Trillions. A number so large that human history disappears completely beside it. If all of recorded civilization were compared to a single grain of sand, the future lifespan of some stars would still feel endless. The universe moves patiently. Nothing rushes. Galaxies rotate slowly through darkness. Stars are born. Others fade away. Black holes drift silently between them. And space itself continues expanding outward in every direction. This expansion was first discovered when astronomers realized distant galaxies were moving away from us. The farther a galaxy is, the faster it appears to move away. It means the universe is growing larger every second. And strangely, scientists discovered the expansion is accelerating. Something invisible is pushing galaxies apart faster over time. This mysterious force is known as dark energy. No one fully understands what dark energy is, yet it may control the future of the entire cosmos. One day, galaxies beyond our local group may become completely unreachable. Their light will never arrive here again. The night sky of the far future could slowly grow darker as distant galaxies disappear beyond the observable universe. You drift deeper into space. The stars around you feel calmer now, softer, more distant. Far away, a giant elliptical galaxy glows faintly against the darkness. Inside it, ancient stars orbit quietly around a supermassive black hole hidden at the center. Even black holes will not survive forever. According to theoretical physics, they slowly lose energy through Hawking radiation. Over unimaginable lengths of time, they may eventually evaporate completely. The process is incredibly slow. A single large black hole could survive for numbers of years, almost impossible to describe. Yet even they may one day fade into darkness. The universe changes constantly, but always slowly, patiently, quietly. You continue drifting through the endless cosmos. No destination ahead, no urgency behind you. Only stars, galaxies, and silent motion stretching across eternity. The deeper you travel into the future, the quieter the universe becomes. The galaxies grow farther apart. The spaces between stars widen endlessly. And still, the cosmos continues forward through time. Ancient, vast, endlessly calm. The darkness around you no longer feels empty. It feels peaceful, like an infinite ocean carrying the universe gently toward its final night. As billions of years continue to pass, the universe slowly begins to change in ways no human civilization will ever witness. The stars that once filled galaxies with brilliant light begin disappearing one by one. Some explode violently as supernova. Others fade quietly into darkness after exhausting the last of their fuel. Entire regions of space grow colder and dimmer over time. You drift silently through this distant future now. Far behind you, ancient galaxies glow faintly like memories slowly fading away. Ahead, the cosmos stretches outward forever. The universe has become older than almost anything the human mind can imagine. Trillions of years have passed. Earth no longer exists. The sun disappeared long ago. Even the brightest stars of the modern universe are gone. Only smaller stars remain now. Red dwarfs. Tiny stars that burn slowly and carefully for unimaginable lengths of time. These stars are different from the sun in almost every way. They are cooler, smaller, far dimmer. Yet they survive far longer than larger stars ever could. Some scientists believe certain red dwarfs may continue shining for up to 10 trillion years. That is nearly 1,000 times longer than the current age of the universe. Around many of these ancient stars, frozen planets continue orbiting silently through darkness. Some worlds are covered entirely in ice. Others drift through space without any star at all. These wandering planets are known as rogue planets. They move alone through the galaxy after being thrown away from their original solar systems by gravity. Without sunlight, their surfaces become unimaginably cold. And yet, some scientists believe life could still survive beneath thick layers of ice, hidden near underground oceans warmed by internal heat. The universe is filled with possibilities stranger than fiction. You continue drifting through a galaxy far older than the Milky Way of humanity's time. Most bright blue stars are gone now. Only deep red light remains scattered across the darkness. Galaxies themselves have changed as well. Long ago, the Milky Way and Andromeda collided. Not suddenly, but slowly over millions of years. Their spiral structures stretched apart and merged together under gravity. Eventually, they formed one enormous galaxy. Future astronomers once predicted this merged galaxy might be called Milkomeda. By this era of the universe, almost all nearby galaxies have already merged together. The expansion of space has pushed distant galaxies too far away to ever be reached or even seen. The observable universe has become smaller, darker, lonelier. Future civilizations, if any still survive, may never know other galaxies existed at all. The evidence will have vanished beyond the expanding edge of space. You drift between ancient stars, glowing softly in the darkness. Many solar systems are now billions upon billions of years old. Some planets orbit dead stars known as white dwarfs. These stellar remnants slowly cool over unimaginable stretches of time. At first they glow white hot, then orange, then red. Eventually they become dark, invisible objects drifting silently through space. Scientists call these theoretical remnants black dwarfs. But after exhausting its fuel, gravity crushed its core inward during a supernova explosion. What remained became one of the densest objects in existence, a neutron star. So dense that a spoonful of its material would weigh billions of tons on Earth. Some neutron stars rotate hundreds of times every second. Others emit beams of radiation across the galaxy like cosmic lighthouses. But this one has grown old now. Its rotation has slowed. Its light has faded. Like the rest of the universe, it too moves gradually towards silence. You continue forward through deep space. The darkness around you becomes even larger now. Galaxies are separated by unimaginable distances. Most stars are gone. Only faint red dwarfs and cold stellar remnants remain scattered across the cosmos. The future universe is quieter than the modern one. Not empty, not lifeless, just calm, ancient, endlessly patient. The stars above you glow softly against the darkness one final time before fading farther into the distance. And as trillions of years continue passing silently through the cosmos, the universe drifts gently onward toward an even deeper and darker future still waiting ahead. The universe has become very old now. So old that almost every bright star that once illuminated the cosmos has already disappeared. Galaxies that were once filled with blue light and glowing nebulae now drift through darkness in near silence. Only faint red stars and ancient stellar remnants remain. You continue moving through this distant future peacefully. The darkness around you feels endless, not frightening, just quiet. A silence stretched across trillions of years. Far ahead, an old red dwarf star glows softly in the blackness. These small stars are now among the last true stars still shining anywhere in the universe. Unlike large stars that burn their fuel quickly, red dwarfs live slowly. They conserve energy carefully and can survive for astonishing lengths of time. Some may continue glowing for over 10 trillion years. By the standards of the future cosmos, they are almost eternal. Around one of these ancient stars, a frozen planet drifts silently through space. Its oceans froze billions of years ago. Its atmosphere became thin and cold over time. The surface is covered in endless ice, reflecting faint red light from the dying star above. And still, gravity holds the system together quietly as it moves through the galaxy. You continue drifting onward. The galaxy itself has changed greatly. Long ago, spiral structures disappeared. The beautiful arms once visible in galaxies like the Milky Way no longer exist. After countless collisions and gravitational interactions, most galaxies have become large elliptical collections of old stars. Smooth, dim, ancient. The universe no longer creates many new stars now. Most of the gas needed for star formation was already consumed long ago. The great stellar nurseries of the past have faded. Nebulae that once glowed with newborn stars are mostly gone. The cosmos has become a quieter place. Far in the distance, something massive moves through the darkness. A black hole. Invisible, except for the faint bending of light around it. Black holes now dominate many regions of the universe. Some are the remnants of dead stars. Others are supermassive giants hidden at the centers of ancient galaxies. Over billions upon billions of years, these black holes continued growing by consuming stars, gas, planets, and even other black holes. Some became unimaginably large, objects with masses billions of times greater than the sun. You drift closer carefully. Around the black hole, old stars orbit silently, like ghosts circling an invisible abyss. Gravity here is powerful enough to bend space itself. Light curves around the darkness. Time slows near the event horizon. Everything feels heavier, slower, more distant. According to Einstein's theory of relativity, gravity affects the flow of time. Near extremely massive objects, time passes more slowly compared to regions farther away. If someone could somehow remain near a black hole safely, they would experience time differently from the rest of the universe. Hours for them could become years elsewhere. The universe is stranger than early humans ever imagined. Space bends. Time stretches. Invisible matter shapes galaxies. And black holes quietly distort reality itself. You continue drifting past the ancient black hole. Its darkness slowly disappears behind you. Ahead lies a region almost completely empty. A cosmic void. These enormous voids existed even in the modern universe. But now, they have grown larger than ever before. Some stretch across hundreds of millions of light years, with almost nothing inside them. No bright galaxies. No glowing clusters. Only occasional lonely stars drifting through endless darkness. The farther the universe expands, the larger these voids become. Galaxies continue moving farther apart as dark energy pushes space outward. Scientists still do not fully understand dark energy, yet it may determine the ultimate fate of everything. Without it, gravity might eventually slow the expansion of the cosmos. But observations suggest the opposite is happening. Expansion accelerates over time. The universe grows emptier every second. You drift quietly through the cosmic void now. There is almost no light here, only deep darkness stretching forever in all directions. And strangely, it feels peaceful. The universe has become calm with age. No crowded galaxies nearby. No brilliant explosions lighting the sky. Only silence. Only time. Far behind you, the faint glow of an ancient galaxy slowly disappears into the distance. Ahead, more darkness waits. More empty space. More endless expansion. The stars of earlier ages are now little more than fading memories scattered across eternity. And still, the universe continues moving forward, patiently, quietly. As trillions of years pass in silence, the cosmos drifts ever closer toward a future where even the last remaining stars will finally disappear into darkness forever. The universe is entering one of its final great eras now. An age where true stars have almost completely vanished. The bright skies that once filled galaxies with light exist only in the distant past. Most of the cosmos has grown dark, cold, and silent. You drift slowly through that ancient future. Far behind you, the last red dwarf stars fade one by one into darkness. For trillions of years they survived, while larger stars disappeared long before them. But even these careful, long-living stars eventually exhaust their fuel. Their light weakens. Their warmth disappears. And at last, the final stars die. A universe lit only by the faint glow of dead objects drifting through endless space. White dwarfs, neutron stars, black dwarfs, ancient black holes. These remnants wander silently through galaxies that no longer create new stars. Gravity continues pulling objects together slowly over unimaginable lengths of time. Occasionally, two dead stars pass close enough to interact. A white dwarf may steal material from another nearby remnant. If enough matter gathers, a sudden explosion can still occur even in this ancient universe. For a brief moment, a lonely supernova lights the darkness once more. Then silence returns again. You continue drifting through a dead galaxy, billions of years older than the Milky Way ever became. Most visible light has disappeared here. Only occasional dim red glows remain scattered among ancient stellar remnants. The galaxy itself feels empty now. Wide regions of darkness separate the remaining objects. Over time, gravity slowly ejects stars and planets from galaxies altogether. After enough close encounters, many objects gain enough speed to escape into intergalactic space forever. Galaxies gradually lose their structure. They unravel slowly across trillions upon trillions of years. Far ahead, an enormous black hole waits silently at the center of the galaxy. Once, billions of stars orbited around it. Now, only a few remain. The black hole has consumed countless stars over cosmic history. Gas clouds, planets, even other black holes. And still, it remains hungry. Black holes are among the strangest objects in existence. Their gravity becomes so intense that beyond a boundary called the event horizon, nothing can escape. Not matter, not radiation, not even light itself. For a long time, scientists believed black holes might survive forever. But modern physics suggests otherwise. In 1974, physicist Stephen Hawking proposed that black holes slowly emit tiny amounts of radiation due to quantum effects near the event horizon. This process became known as Hawking radiation. It means black holes gradually lose energy over time. The larger the black hole, the slower this process happens. A supermassive black hole could survive for numbers of years so enormous they barely fit into mathematics. Yet, even these giants are not eternal. You drift closer to the ancient black hole. Its darkness bends the faint starlight around it, like ripples distorting reflections on water. Nearby space feels warped. Time itself moves differently here. And yet, everything remains calm. No sound, no sudden movement. Only gravity shaping the darkness patiently through eternity. Around the black hole, cold, dead planets continue orbiting silently. These worlds no longer receive warmth from any star. Their surfaces are frozen harder than stone. Atmospheres vanished long ago. Oceans became endless fields of ice buried beneath darkness. The future universe has become a place of remnants, echoes of earlier cosmic ages drifting through silence. You move farther away from the black hole now. The surrounding galaxy fades into darkness behind you. Ahead lies intergalactic space once more. Vast, empty distances larger than anything human beings once imagined possible. Dark energy continues stretching the universe outward. Galaxies that once filled the sky are now separated by impossible distances. Light from many regions of the cosmos will never arrive anywhere again. Entire portions of the universe become permanently isolated from one another. The cosmos grows emptier with every passing age. And still, time continues forward, patiently, quietly. Far in the distance, one final red dwarf star glows faintly against the darkness. Perhaps among the last true stars still alive anywhere in the universe. Its dim red light spreads softly across the ancient void. Then, after trillions more years pass, even that final light fades away. For the first time since stars were born in the early universe, darkness truly dominates the cosmos completely. No bright suns remain, no glowing nebulae, only cold remnants drifting through infinite night. And as the universe settles deeper into silence, you continue drifting peacefully through the endless dark, carried gently forward through the final ages of cosmic time.